Okay, so if we look at your view here, we're recording, and we look at the student view. So tonight we're going to talk about pH and passive transport for the Lab 1 assignment. So you go down here, you click on Materials for 125. Let's click on pH right here. Let's open a file. Okay, so you have a copy of this. Read through the objectives. We're not going to be able to do the lab, obviously, but we should know this material here. Water will break up some of the water. Very, very few molecules of water will break into H plus and OH, and there's equal number. So that's why water is neutral. If you have an ionic compound such as salt, when it's put in water, it breaks up or dissociates into sodium and chloride. If you don't know what dissociate means, you just do this and you click on it. And will it give you something? No, give you synonyms? No, well, it doesn't work. Does that work? Paste options, link, synonyms. Let's see what it gives us. Okay, well, look it up on the web. Okay, so hydrochloric acid is a strong acid. Acids are defined by they break up in water to form H plus, and it's called a conjugate base. Sodium hydroxide is a strong base. Bases dissolve to form hydroxide. When ammonia is put in water, it picks up a hydrogen and becomes NH4, but it's a base because it produces hydroxide in solution. The pH of a solution is the negative log of the hydrogen ion concentration. If a solution is 7, it's neutral. If it's less than 7, it's acidic. If it's greater than 7, it is alkaline and or basic. So make sure you read through all of these directions or this information. Okay, so if I have a pH of 2 versus a pH of 3, the pH of 2 has 10 times more hydrogen ions than the pH of 3 because this is a logarithmic scale and powers of 10 define the concentrations of hydrogen. If I have a pH of 2, it's 100 times more hydrogen ions than pH of 4 because there's a 10 to the 3 and a 10 to the 4. Okay, so the Lab 1 test will have questions taken from here. You can print this out, look at it, your choice. We're not going to be able to do the experiment, but let's look at what we're going to talk about more. Okay, so cells release products that can change the pH in the body. Weak acids and bases do not associate completely, and strong acids do. We can take weak acids and their base and make a buffer. A buffer is a solution that minimizes the change in pH. If you don't have buffers in your blood and plasma, such as bicarbonate, you're going to die. So a buffer is made of a weak acid and a weak base. And it's able to work by supplying hydrogen ions to lower the pH or supplying hydroxide ions. So a buffer is a solution that minimizes the change. The buffers consists of a pair, a weak acid and a weak base. So if an acid is added to a buffer, the buffer combines with the extra hydrogen ions to neutralize them. If a buffer has hydroxide added, it will release hydrogen ions to help minimize the change. So make sure you read through this introductory material. This is the information covered in Lab 1. Okay, so I think that's all the material we have there. Okay, let's minimize that and go to passive transport. Okay, so know what a percent solution is. If you put 5 grams of glucose in 100 milliliters of water, that's 5% glucose. If you put 0.9 grams of sodium chloride in 100 milliliters, that is a 0.9%. That's physiological saline. Molarity. All you need to know is that if you put 1 mole in a liter of water, that's a 1 molar solution. So 1 mole of sodium chloride, if you add up the atomic mass of sodium and chloride, you get 58.5. So that's called 1 mole. If you put 1 mole in a liter of water, that's a 1 molar solution. So what's the relation? What is osmosis? Osmosis is the diffusion of water through a selectively permeable membrane and is caused by the unequal distribution on both sides of a membrane. So let's jump ahead and we'll come back. So if I have a red blood cell and it has 300 milliosmoles as its concentration, and outside the solution has 300 milliosmoles, water will move in and out and there'll be no volume change. If you put a red blood cell, this is called hypoosmotic because its concentration is less than this concentration. Water is going to move into this red blood cell because there's less dissolved material and more water. So the net effect will be that water will move into this cell and cause it to burst. On the other hand, if you put a red blood cell in a solution that is more concentrated than inside the cell, since there's more water here and less dissolved solute, the water moves through the membrane and this cell will shrink and it will cause crenation or shrinking and it shrivels. Okay, so let's go back to what osmosis is. So osmosis is the movement of water through a selectively permeable membrane, and it's caused by the unequal distribution of the amount of water on one side and the amount of non-penetrating solute. So water is drawn toward the side of the membrane with higher solute concentration. So what does that mean? So right here, since the concentrations are equal, water will move in and out at the same rate. Here you have a higher concentration of solute. Water will move overall into the cell and cause it to burst. In the next situation, this is a hyperosmotic solution. So the net movement of water is out of the cell since there's more water here compared to outside because 350 means there's more dissolved solute that can't penetrate the cell. And so water will move out of this cell and this cell will shrink. That's all we got to know about this handout. So make sure you know what osmosis is. This is very important because suppose you're in a situation where you're swimming in fresh water, and you begin to lose you get tired and you begin to go under, and you gulp fresh water. That fresh water will go into your esophagus and into your lungs. And since it has a higher concentration of water, that water is going to diffuse into your blood vessels, cause your red blood cells to swell and burst. That will release potassium, and you'll probably die of a heart attack. If you're swimming in seawater, you will have a situation where the concentration of the seawater is very similar to your plasma. So in that case, you will die from asphyxiation. That's sort of morbid, but the movement of water in and out of cells is incredibly important, and the body spends a great deal of energy in keeping the pH constant and keeping the concentration in and out of cells constant. Okay, so those two are there. Let's minimize that. And let's go back to the meeting. Let's turn this one off. That's another separate one. Stop recording. Stop